We're going to be talking about similarity and specifically regarding triangles. Similarity regarding triangles. Remember to turn off distractions and also record both your location and the time that you are watching this video and taking notes. Let's start with a review question. This is from the previous chapter. State whether or not the triangles are congruent. If so, specify the shortcuts side, 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 angle, side, angle, or angle, angle, side. Let's take a closer look here. In the first set of triangles, we see that we have a pair of congruent sides, then a pair of congruent angles, and a third pair of congruent sides. So in this first set, it will be side, angle, side. In the second set, we have a freebie. We're going to mark this one with a hatch mark and put an S. Then we also have another pair of congruent angles. Then another pair of congruent angles. This side is attached to only one set of angles. So the reasons why this is congruent is angle, angle, side, or side, angle, angle, which is the same thing. Take a moment and complete these next 5 on your own, and the answers will be provided for you in about 1 minute. Okay, in this first one, we see that we have a pair of congruent angles here. And then here we have a pair of congruent sides. And this is a pair of congruent sides. Now look very carefully. This angle is not squeezed between the sides. So what we have going on here is not side, angle, side, which is an appropriate shortcut. What we have going on here is side, side, angle. That does not force congruency. So these particular sets of triangles are not congruent. Let's take a look at this one. We have a pair of sides, pair of angles, and another pair of angles. This one is angle, angle, side, or side, angle, angle. This one, all we have is that we have 3 sets of angles. We do not have any sides involved. Because of that, they're not forced to be congruent. They will keep the same shape, but the size of the triangles could change. So we would say this is not congruent. Take a look at this last one. We have a set of vertical angles. We have a pair of A's, another pair of angles, and then a side. So we would say, yes, these are congruent, again, by angle, angle, side, or side, angle, angle, which is the same thing. Now today we're going to relate similarity specifically to triangles, Just like there are shortcuts for congruency, here there are 4 shortcuts to congruency that you are familiar with. And shortcuts to congruency mean if a minimal of these 3 combinations are congruent, side, 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 angle, side, angle, or angle, angle, side, then we know the triangles are absolutely the same, which are congruent. Just like there's shortcuts for congruency, there's shortcuts for what's called similarity. Remember, the definition of similarity is things that have the same shape but different size. And in this case, there are 3 shortcuts to similarity. 3 shortcuts to similarity. The first shortcut is if you have 2 congruent corresponding angles, then the triangles are similar. 2 congruent corresponding angles. That would be something like this. A pair of angles and another pair of angles. We have 2 pairs of angles which are congruent. That forces the triangles to be similar. Again, not congruent, but the same shape but different size. That means similarity. One of the most common illustrations of this is if you have overlapping triangles. Let's say here. So you were given a scenario in which you had 2 right overlapping triangles. In this case, we have a larger triangle, which I have in light green. I'm going to pull that out so it's easy to see. And I have a smaller triangle, which we have in blue. And in this scenario, we are told that we have 2 right angles, so they at least share a right angle. But if you look closely, they share exactly that, what I'll call the toe angle as well. So we would say that these are similar by angle-angle similarity. This is what's called a reflexive angle. The next shortcut you should be familiar with is if you have 3 side ratios which are equal. 3 side ratios which are equal. Let's say this triangle has a side length of 3, 4, and 5 centimeters. And this has 6, 8, and 10. If we look closely, we have a side ratio of here to here of 2 to 1. Side ratio, here to here, 2 to 1. Side ratio, from here to here, 2 to 1. All 3 side ratios are equal, therefore we would say these triangles are similar. Same shape, different size. Last one you should be familiar with is side angle side similarity. And this says if you have an equal side ratio, then you have 1 pair of congruent angles and then another set of equal side ratios, then the triangles will be similar. An example of this would be this scenario. Notice we have an equal pair of side ratios, 8 to 4, that's 2 to 1. Then we have a pair of congruent angles, 2 right angles, that gives us our angles. And then we have another pair of equal side ratios, 2 to 1. Therefore, we would say these triangles are similar by the side angle side similarity shortcut. This would be the side similarity shortcut. Let's take a moment and practice this. We're going to see which one of these qualify for which shortcut. In our first diagram, we have parallel. If we have parallel, let's stretch it out. If we have parallel, it means we have armpits of the Z going on, which would be something like this. So that would give us 1 pair of congruent angles We would also have vertical angles which are congruent. So this first one is going to be similar by angle-angle similarity because of the vertical and the armpits of the Z. Next one, we have a pair of congruent angles. And of course we have vertical angles going on in the middle. So the next one is also angle-angle similarity. You take a moment and determine which similarity is going on for these pairs and which similarity is going on for these pairs. Or you may choose not similar. Let's check this. We have 24 to 42. 6 goes in there 4 times, and 6 goes in here 7 times. Now we'll check 32 and 56. 8 goes in there 4 times, 8 goes in there 7 times. So my side ratios are equal, and then I have vertical angles. Therefore, this would be side, angle, side similarity. My side ratios are equal, and I have one pair of congruent squeeze angles. Let's check here. Now, when triangles, you're not quite sure what belongs to what. It's the easiest just to label this small, medium, large. Then we come over here, we label small, medium. Oops, let me keep my colors consistent here. Medium is green, medium, and large. So we're going to compare small to small, 24 to 54, and then medium to medium, 35 to 81, and then we're going to compare large to large, which is 40 to 90. So 24 to 54, 6 goes into 24 4 times, 6 goes into 54 9 times. And then here, the easiest way also, you could just divide. We're going to go 24 divided by 54, and we get 0.44, repeating. 35 divided by 81, 0.43, repeating. And then 40 divided by 90, 0.44, repeating. So these are similar by side, side, side similarity. Before we go on to our next section, we need to talk first about dimensions. We need to talk about dimensions. The 1, 2, and 3 dimensions. The first dimension is just length. Things that have length. Things like a piece of string or rope or something of that nature. In math, the simplest one-dimensional object is a line. Then we have 2 dimensions, which is length, and then something that also has width. A common 2-dimensional object would be a piece of paper or in geometry, we would call that a plane. Three-dimension is, of course, length, width, and height. A three-dimensional object that you'd be familiar with in geometry, something that has both length, width, and height, would be a prism. Or you might know them as boxes. That would be 3D. So something that just has length is one dimension. Something that has length and width is 2 dimensions. Something that has length, width, and height is 3 dimensions. Now when you think of the perimeter of something, I want you to think of a picket fence. A picket fence. A perimeter is like a fence around a yard. If you were to have the perimeter of something, it would be the fence around a yard, and then of course the yard would be area. So let's clarify this. The grass would be considered a concept of area, and then the picket fence would be the perimeter, around, going around the area. Now the question is this: how many dimensions is perimeter? Dimensions of perimeter. Since perimeter is going around 2 dimensions, it doesn't make it 2-dimensional, because if this was string or even fencing, I could unwrap the fencing into 4 lengths. Fencing can be unwrapped. Therefore, perimeter is just a concept of length, which makes it a one-dimensional concept. So, since perimeter is a one-dimensional concept, and sides are a one-dimensional concept, they have the same ratio. So one thing you want to keep track of is that when you have the scale factor, a side-to-side ratio, it's going to be the same ratio as perimeter over the perimeter. Let me give you an example. If we were to compare this side to this side, side over side, it would have the same reduced ratio as if we compared this entire perimeter to this entire perimeter. Side over side equals perimeter over perimeter. Why? Because they're both one-dimensional concepts. Let's do one example. We're going to find the perimeter of triangle ABC. Perimeter of A, B, C. I have overlapping triangles, so I'm going to pull this out here. We have a right angle here. Let's pull out what we do have. This is A, this is B, this is C, this length is 5. This length right here was 3, but that's only a portion, and then we have this middle. So we're trying to find the perimeter. Now in order to get the perimeter, we first have to get a side-to-side ratio. You should make note that you have an additional triangle here that's overlapping, and whenever you have overlapping triangles, the first thing you should attempt to do is trace and pull them out. So this triangle right here, we're going to trace it. We're going to pull it out. Here's our right angle there. So this was C. This is D. This is B. This is 3, this is 4, this is 5. If you look very carefully, the two triangles, the yellow and the blue, share that angle right there, angle B. So we can say these triangles are similar by angle-angle similarity. They at least have two angles congruent. Now, let's label our small, medium, large. In this triangle, this is our small side. This is our medium side. And this is our large side. In this triangle, our small is going to be 3. Our medium is going to be 4. And our large is going to be 5. So when we compare side to side, we have to make sure we compare the proper sides. In this triangle, the only side length we have is 5, and that's the small side. So we can compare small to small. So we're going to go like this. Side over side equals perimeter over perimeter. And in this case, the sides we're going to compare are small to small. So we're going to go 5 to 3. Equals our unknown perimeter, which is the perimeter of ABC, over this perimeter, which we do know, which is 3 plus 4, which is 7 plus 5, which is 12. Now we cross multiply. 5 times 12 is 60, equals 3 times the perimeter. Divide by 3, and we get our perimeter is going to equal 20. So the perimeter of ABC is 20 units. In altitudes, it's the same concept. When you have a side-to-side ratio, side over side, it's going to equal also the altitude to the altitude. Why? Because altitudes are one dimension as well. Side to side equals altitude to altitude. Let's do an example here. We are told that JKL is similar to STU. So let's go ahead and draw JKL. We don't know what these look like, so we're just going to make them look the same shape but different sizes. So this is JKL, and then we have STU. We're going to draw an altitude from K to JL, and we're going to label that intersection M. We're going to draw an altitude from point T to SU. We're going to label that point of intersection N. K to M we're told is 5. T to N we're told is 7. The length of J to L, the whole side, is 12.5. Find the length of SU, which we don't know. Well, what we do know is that the side over side ratio equals the altitude over the altitude. So I'm going to go left to right, side to side. 12.5 over unknown equals our altitude 5 over our known 7. Cross multiply. 5x equals 12.5 times 7. 87.5. We're going to divide both sides by 5. We're going to get 17.5. Medians have the same concept. If we're to compare side to side, it's also going to equal median to median. because again, medians are one dimension. Side to side also equals median to median. So to recap, we have side over side equals perimeter to perimeter. Side over side equals altitude over altitude. And side over side equals median to median.